Today, we are designing an enemy for our car game, an awesome robotic dinosaur. This enemy will add excitement and challenge to our wasteland adventure. First, we need to decide what kind of enemy fits our game. I am going for a hybrid of a T-Rex and robot, of which I got the reference from Pinterest. It will have glowing red eyes, armor plating, sharp teeth and claws, and will have a special feature to transform itself into a vehicle and chase the player down the path and cause damage. I start with a rough sketch looking at the reference, focusing on its silhouette. I start by sketching every part separately so that it would be easier while creating them digitally. Once the base form is solid, I refine it with the details like wires, arm joints, and other attachments. Now that we have a sketch, let's digitalize it. I bring my sketch into Adobe Illustrator and begin constructing the base shapes using the pen tool. I carefully outline the structure with bold, striking lines and apply a gritty metallic texture to give it a rugged, battle-worn look that fits the game's one-turn setting. Once I'm satisfied with overall structure and detailing, I move on to refining each individual part separately to maintain a high level of precision. For animation purposes, I make sure to separate the dinosaur's body into distinct layers. This includes the head, arms, legs, tail, and weapons, ensuring that each piece can be animated independently. This approach makes rigging and animating in the game engine much more efficient and allows for more dynamic movement. Now, let's focus on adding some intricate details to our robotic dinosaur to make it stand out in the game. I carefully choose a color palette that enhances its mechanical look while ensuring it contrasts well against the game's environment. By adding highlights, shadows, and metallic reflections, I can create a sense of depth and realism, making the character pop on screen. Now that all the individual parts have been designed, it's time to assemble them into their correct positions. By carefully placing each component in its designated spot, we now have a fully formed robotic dinosaur enemy that is ready to be integrated in our game. Seeing it come together as a complete character is always an exciting part of the process. Now, let's import our character's PSP file from Photoshop. Since this is a multi-layered sprite, we will be using Unity's 2D animation package to rig it up. Once we have our sprite selected, we jump into the sprite editor and then into the skinning editor. This is where we define the skeleton structure of our character. Starting with the main spine, following by the neck spine, we built a solid base. From here, we add bones for the limbs and tail, making sure they all parented to the main spine. It's important to keep an organized structure to make animation easier later on. Now we generate automatic weights for the mesh. This determines how much influence each bone has on different parts of the spine. We can tweak this by selecting each mesh and adjusting how it deforms when the bones move. To check if everything is working correctly, I rotate the bones and see how the sprite responds. Looks good so far. One last thing, labeling each bone for easy navigation. Trust me, this will save a ton of time later. And with that, we apply our changes. Now on to inverse kinematics or IK. This makes animation much easier by allowing us to control entire limb movements with effectors instead of rotating each bone manually. I set up effectors for each bone and add an IK manager to the main parent bone. This lets me create IK targets, making our character's movements more natural and efficient. And with that, we are ready for animation. Oops, forgot to add bones for the mouth. I want to animate the monster's expressions. I will need those. Let's fix that real quick. Now, let's start simple. The first animation is the monster sleeping. Since it's just a rest pose, it's only one frame. Now, exactly an animation. But it's a start. Time to make things more fun. For the walking animation, I move its leg, arms, and body, setting keyframes accordingly. This makes the character looks like stretching and getting up. Looks like I missed assigning bone influence to the front wheel. A quick fix. And we are back on track. After some final tweaks, our monster walking animation is done. A quick tip. Don't forget to turn loop time off in the animator for one-time animation just like this. And now we move on to the walking animation. Using the same keyframing process, I animate its movement, making sure the legs sync up naturally. It's really starting to come together. The monster follows a simple movement system. It has acceleration and deceleration, smoothly reaching its max speed when moving. The move function updates the velocity using vector to lerp to create a gradual motion instead of abrupt changes. The monster starts in a sleeping state. When triggered, it plays a wake-up animation before activating movement. Now on to attacks. When the player enters range, the monster stops moving and switches to attack mode, dealing damage every 0.2 seconds in a core routine. If the player leaves, it resumes chasing. To prevent animation conflicts, I am using booleans like is awake and is attacking to toggle between movement and attack states seamlessly.